Welcome to our explainer on how blockchain technology works. Today we'll take a deep dive into the technical aspects of blockchain, breaking down its essential components and mechanisms to understand its revolutionary potential. At its core, a blockchain is a decentralized ledger that records transactions across a network of computers, or nodes. Unlike traditional ledgers that are maintained by a single entity, a blockchain is distributed, meaning that every participant on the network has an identical copy of the entire ledger. This decentralized nature ensures that the record is not only secure, but also highly transparent. Transactions can be tracked and verified by anyone with access to the network. Each block in a blockchain consists of three key components: the data, a unique cryptographic hash, and the hash of the previous block. The data section holds transaction details. In the case of a cryptocurrency blockchain like Bitcoin, this information includes the sender's address, the recipient's address, and the amount of cryptocurrency being transferred. Additionally, it could also contain timestamps, and in more complex blockchains, data may represent smart contracts or other asset types. Next, we have the cryptographic hash. A hash is a string of characters created by passing the block's data through a cryptographic algorithm. This hash serves two critical purposes. It provides a unique identifier for the block and helps maintain the integrity of the data. If even a single character in the block's data changes, the hash will alter drastically, alerting the network to potential tampering. Each block also contains the hash of the previous block, creating an unbreakable chain of information. This interconnection makes it virtually impossible to change the data in a single block without changing all subsequent blocks, thereby requiring an overwhelming amount of computational power to execute such a modification. Now let's discuss decentralization in more detail. Traditional databases often rely on a central authority, which can be prone to failures and corruption. In contrast, blockchain operates on a distributed peer-to-peer network where every participant, or node, maintains their own copy of the blockchain. This setup vastly increases security, as there is no single point of failure. When a new transaction is initiated, it's broadcast to the entire network. Nodes then validate this transaction using consensus algorithms. Two of the most common algorithms are proof of work and proof of stake. Proof of work involves solving complex mathematical problems, a process that requires significant computational resources and energy. This makes it costly and time-consuming for malicious actors to attempt to manipulate the network. On the other hand, proof of stake allows validators to create new blocks based on the number of coins they hold and are willing to stake as collateral. This approach is seen as more energy efficient and encourages validators to behave honestly, as they have a financial stake in the network's success. Once validated, the transaction is bundled into a new block, which is then appended to the blockchain. This process not only secures the transaction, but also updates every participant's copy of the ledger in real time, ensuring that everyone has access to the most current information. The advantages of blockchain technology are profound. It offers enhanced security through cryptography, increased transparency due to its open nature, reduced transaction costs by eliminating intermediaries, and streamlined processes across various sectors. As blockchain technology continues to evolve, its applications extend well beyond cryptocurrency. In supply chain management, companies can trace the movement of goods from manufacturers to consumers, ensuring authenticity and reducing fraud. In healthcare, patient records secured on a blockchain can be shared across institutions while maintaining privacy. The finance sector is exploring faster and cheaper cross-border payments, while voting systems could benefit from increased security and transparency. Understanding blockchain's inner workings is crucial, as we move forward into an increasingly digital future. As this technology matures, it has the potential to transform how we conduct transactions, manage data, and interact in our global economy. Thank you for joining us today. If you found this video informative, please subscribe for more content on technology and innovation.